And looks like we're live. Hopefully. Let me double check. Yes, we are. Awesome. Okay. I actually have my pancakes. Forgot to mention, because it is early and it's a Saturday. It's a special day. Good Docker files, slim containers, and building our own cloud native tools. This is how we started with the first stream that we had. We talked about the GoFile project, uh, which is a custom front end for BuildKit to create minimal container images for Go applications. And now we get a chance to do something similar, but from a different angle. So what is the key component of a good Docker file? It is the base image, right? It
Yep.
is.
Probably not necessarily a Docker file, right? It's like what is a good component? Oh, sorry, what is the main component of the final good image, right?
Yep.
Docker file or not? Yeah. And
Exactly.
then, yeah.
Exactly. And obviously everybody knows the Chainguard images, right? And everybody knows that they're expensive, at least everybody who try to use them officially. But not everybody knows that you can build your own Chainguard images for free. And this is why we're meeting today, and this is what we're going to be exploring. And yeah, and why would you bother creating your own Chainguard base images? Because the standard images have quite a few problems. And if you use the standard image, it's going to be big and it's going to have a lot of vulnerabilities.
Yep.
And Ritvik will show us what it looks like, and then we're gonna explore the awesome project you have, because this is, yeah, when I saw the project, I thought this is great. This project shows other people that you can do it yourself, and you can have a lot of different images there if you use the project.
One thing I'd say is like Chainguard has like they have been the standard in the industry for minimal container images, like without a shell. They have like very less number of CVs or almost zero for some of those images. So we are trying to replicate that. So yeah, I mean that's what our like the project minimal is about.
Cool. And do you have the console or the web pages that show the vulnerabilities and just the basic image information?
Yep.
Okay, awesome. Now, while I'm adding this to the screen, Ivan, like you've done a lot with Docker files and container images, and you've seen a lot of containers and base images. What are your thoughts about just the overall landscape when it comes to the base container images and the best practices and the gotchas that you normally have to deal with there?
Yeah, that's a great question. So, as you already mentioned, there is this probably the key component of a good container image is its base. And then the second part comes from the like application layers that comes after the base. And regardless of how good or bad, and by bad I mean size-wise and or vulnerability-wise, your base is, it can also impact how you will be able to compose your application layers on top of it, because there is always a trade-off. And if you try to optimize your base image too much and go for a like for the most trimmed down and for the most slim option out there, you will complicate your life on building the like the application layers later on, versus when you don't optimize your base at all and go straight to the, I don't know, Python 3 dash latest or Python 3 dash stable, whatever. It looks like an option for a base image. It works, and then your application layers can also be easily added on top of it, because pretty much every apt get install command you would run to install your I don't know, whatever shared libraries your Python code needs, it will all work like a charm. But the problem is the final image will be huge, and yeah, so it's always a trade-off. Like the typical solution here would be, hey, try to restructure your Docker file, right? And try to use a multi-stage build so that during the build step, you can use a more like fully fledged base image. So all your installation steps would be rather simple. But then when you are about to go to production, you would carefully copy all the parts of all the needed parts from the base, from the build stage into the runtime stage. And that's where you learn that actually, especially for Python, for some languages it's easier, like Go, for instance, you would have a fat base with the compiler, but then the artifact is just like a single binary or something, so copying it is easy, maybe some static access as well. But for a Python base, for instance, copying all the stuff that you need, and only the stuff that you need from the build stage into the production stage becomes, well, a challenge on its own. And I tried to it's been a while, right? And we tried to several avenues to improve the images. So we had a company. We tried to ship an optimization solution. Then we tried this good Dockerfiles project when we tried helping people manually to rewrite their Dockerfiles. And then I had this little campaign of my own to somehow popularize these techniques by writing about them and doing some diagrams and even practical challenges where people could do this. And somehow getting people's attention at these topics is pretty hard, most likely because everyone wants to run containers, not to build images. So yeah, it's a multi-dimensional problem to solve. You need to approach it both from the technology standpoint, from the adoption standpoint, and also from the awareness standpoint. So you need to tackle it from all the sides and probably simultaneously.
Yeah, it's a little tricky because it's a low-level problem. It's a low-level problem, and if you're an app developer, you don't always have enough context, and that's not what you're used to doing. And yeah, all of those things you mentioned become a problem. And yes, picking a good base image simplifies some of those problems, and in some cases with the distroless images you mentioned, the ability to customize becomes tricky, and if you don't need anything extra, you're kind of fine. But then if you need something distroless from Google, they don't have a package manager, then you do this tricky thing. Like I've seen a few options, but with the Chainguard images, there's a little more flexibility, and this is one of the reasons we're looking at them. Now, before I bring in the screen, can you switch the tabs to the page that you wanted to see?
Yeah, yeah, I
Okay.
did.
All right. Great. So let's take a look at what the images look like and how things are different.
Yep. So, following up on what Evan said, right? So, if we have a very small image that does not have anything, it's actually no use to anyone, right? You will
Mhm.
still have to add some more, you'll have to install libraries, you'll have to install packages on top of it, which will have their own CVs. Now you are like, it's making your whole distro as like minimal images useless because your image is not, or like you cannot deploy it to production because it does not have anything, and now you're adding on top of it, which is adding CVs. So it's like you're back to zero. So while if people are familiar with Chainguard, right? Chainguard is a company that started this whole notion of minimal images, container images, and they actually try to productionize these images, and they are really good. But as Kyle said, they are expensive as well. Like, so a lot of it depends on the what is your use case, how, like, what are the requirements for your company, what do they expect, and if there's any compliance that you have to go through to make sure you are compliant to certain standards. So that's all. When when Chainguard was all over the internet, and it was actually really good. It's making some really good projects, and it has developed some good open source tooling that they have published for everyone to see and use. And two of them are APKO and Malam. So I can show you APKO GitHub. Let's look into that. So Chainguard's APK project actually wants to promote building container images without a Docker file, as you can see from the description, right? Because Docker file itself, they don't believe in that notion like container images should be built upon Docker file. You don't need a Docker file, and Docker by default run with root privileges and everything, right? So it has some inherent issues by itself. So APK allows you to build OCI images from APK packages, and they have their own way of setting up the syntax, and like they are like YAML files. A simple APK file could be as simple as this. So they expect some information in that, and you can finally build an image that is OCI compliant. So that's one of their projects, and the other project that they have built is called Melang. That is for people to develop. So consider it as like for APK, if you have to build an OCI container images, you need some packages on that images, right? And to build that packages, you can use Melang. So that helps you build APK packages from the source code. So it's like they have these tools for every part of the pipeline where you have to build your OCI container images, and like it's again a YAML file, and they have their own way of defining these images on what to do, how to do all these things. So what got me thinking is, if we have these tools available, we have the source code, and then Chainguard build these images from the source code every day, right? That's what they say. And that's like, and they make sure they are only including stuff into the images that is required for that image to run. They are shellless. Lot like not every Chainguard image is shellless, because you need some images to have a shell. So they have like two different tags where they have a dev tag and their latest tag. So in
Mhm.
Chainguard images, I can show you an example. So if you go to a tag, like this is the Python image on Chainguard. If you see, right, they have latest tag and then they have latest dev. So this is typically not for production use, and it has shell in it. Yeah, so you can see from the disclaimer as well that they have on the website. They have shell in a package manner. So this is for you to test and everything, and then the latest one is for the actual production use, and you can actually see the difference in size, right? The latest dev is 246 MBs and compressed image is 24 MBs. And what got me thinking was, if we have everything that we need to, like, we have these tools, right? We have Wolf, we have APKO, we have Melang. So why can't we build our own images using these tools, and see like if we can have a pipeline where we are building these images every day from the source itself, only including packages that we need, and thinking based on the information that we already have on Chainguard's website, right? Why can't we use that same information to build our own images, right? So
Yeah.
like Chainguard,
And the
yeah,
big
go ahead.
question there, one of the big questions there is, what do you put in the image itself? And there are a few options how to find this information,
Yep.
right?
Yeah. So one of them that I had initially used for my project was this SBOM option here, that is from Chainguard itself, and it tells you, okay, what all different packages are included in that image. we can definitely use that information, right? So if you see, like, we have the type, these are all APK packages, these are all from Wolfie. So Wolfie is Chainguard's own operating system. It's not like your traditional operating system. It does not have its kernel, and it depends on the host to act.
Mhm.
So it won't boot up like on your normal desktop or something. But if you use Ubuntu, right, it's already bloated. If you use Ubuntu as the base image, it's already bloated. It has a lot of packages, libraries in there that you don't even need. So they had to build something from scratch that would suffice their use case. So they came up with Wolfie. It's a really amazing project, and a lot of the Wolfie packages, like, suppose if I were to pick any of them, right, ncurses, this is from the Wolfie and this is APK. So you can also download this APK package and use it in your own library, like your own container image. So Kyle, to answer your question, this was one of the areas that I looked into to while deciding, okay, which package to use if I were to mimic something that Chainguard was doing.
Yeah, and another way to get the list of the packages of a given image is to use obviously the sift tool.
Yeah.
Everybody uses the sift tool to generate S-bombs. And there's also a feature like that in the Wolfie CLI application. There's the image command and the APK subcommand there that allows you to list the packages in a given image. Though the current version of the Wolfie CLI is a little broken because it depends on the SIFT library, and it doesn't initialize the RPM cataloger and all of that. But it does pretty much the same thing SIFT does. The only gotcha there is that the image needs to be downloadable. You need to be able to download it, and then you can run either SIFT or Wolfie CTL on it to get the list of packages. But if you use the website, this is one of the tricks that you shared. You can get the list of packages for the images that are not publicly downloadable.
Yep. So that's one of the things. Like, not all the Wolfie images. Like, if I were to pick an example called, I think for Kafka, if we see, that's one of the chain guard images we have, and I don't think so. If you try to install the latest version, right, you cannot, because this is private, and you need to contact them, as they said here, right? But if you see, like, there are different tabs, and they give you a lot of information about the image. And you have the specifications on, like, okay, it's an APK, yeah, no, and it has a shell. So Kafka image does has a shell on the latest stack,
Mm.
and they have the environment variables as well. You have the raw configuration, so you technically have everything you need to run this image, right? And and then if you were to see the SBOM, you have the list of all the packages that they use to build this image, and sometimes it can go big. So these are not so SBOM, like, they're transitive as well, right? So that's how,
Mhm.
and you can see, like, the source of these names, like, packages. Like, if I were to use Jackson Core, I'm pulling it from Maven. So we have this information, and so yeah, in short, like, if like TLDR, we have the tools, we have the packages that we want to use in our images, we have the, the base operating system, like we can use Wolfie OS, and we have the pipelines workflow if you want to develop this for free. Minimal is just, I would say, like, this could be minimal. Give is an example, like, if some company want to actually deploy this in their own infra and not spend a lot of money, they can follow a simple pipeline or structure like minimal and have their own sets of images and own sets of, like, priorities on update cycle and everything, and they can build something on their own based on using some open source tooling.
So at a high level, the minimal project you put together, in a way, reverse engineers the official images, and it recreates the APKO configuration, but additional packages built from source in order to get the same outcome. So
Yeah,
it's
yeah.
more than just the image configurations from the official Chainguard images
Definitely.
repository that we're going to take a look at the end. If anybody's interested to see how those images could be built, because it's not quite clear right away. If you can build it, it's a little abstract, and there are some gotchas in the setup. So I'm pretty sure quite a few people gave up on it, but we'll see if we'll be able to successfully build something there. But in a way, the first part, you reversed engineered a lot of the images and you filled in the blanks and created the configs. And the second thing, you created this end-to-end pipeline,
Yeah.
right?
I can show you an example. So we were discussing the Python image itself, right? So let's pick Python itself, and two things, right? So some of the packages information. So when I started with minimal, I didn't want to actually develop everything from scratch and like not you
Mhm.
know reinventing the cycle. So a lot of it I relied on using the Wolfie packages because Chainguard has some SLAs where they ensure like their Wolfie packages are updated in certain cadence, and I think it was 24 to 48 hours. I'm not sure about that, but I
Mhm.
relied on that. So I was just pulling those Wolfie packages from like Cypress Python package from Wolfie and using it to build my own image. But so if we take this appco file an example, this is Python .yaml file that we use to build our appco, like the Python container image. If we start looking from the top, right? So we start with the repository information from where it will be pulling these packages from, and then you have list of all the packages what that we need to build this Python container image. We
And
have the
there are a few options when it comes to the repositories. The one that
yeah
you're listing is the main Wolfie repository, but there's a couple of other options which
yeah
is also accessible. So you can install images, packages from those
yeah
repositories, and the main Chainguard repository is, if you look at the number of packages in it, it's almost identical to the number of packages in the Wolfie repository. The difference is about 10 or so packages. So you
yeah
can use either, and then they also have an extra packages repository with about 10,000 plus additional packages that you can leverage. But you
yeah
can point to your own
yeah
repositories. You can build from source, put it in your own repository, and then reference it here in the APKO.
Definitely, definitely. I mean, if some company wants to, if they don't want to actually ping something or pull packages from Wolfie's project, they can have their own APK repository. So they have to be make sure like APKO is compliant with their own repository. And I think it only works with APK packages for now. That's why like we have the Melang tool that helps you build those APK packages, right? So you have the tools for all the different stages in the pipeline, and depending on your use case, right, you can have different packages. So these are all available from the Wolfie OS. If not, you can have your own repository and like signal point your appco APK configuration to that repository, and then you have the information about the user, the work directly. So this is basically, if you see, right, you can actually build a Docker file from this, but this is in a different format. This is not your typical Docker file, but if you try to correlate with all the information that you have on a Docker file, you will find a lot of similarities between them, right? I mean, in Docker file, we do have environment variables, we have the entry point, we have the work directory, and yeah, so
So speaking of that, comparing what APKO gives you versus a traditional Docker file. So the one of the biggest differences there is that you don't have run instructions. So it's more declarative, and you specify the packages, you specify the properties, and Ivan, based on the Docker files you've seen, how often does it become a problem or a need to have those run instructions to configure something, or is it possible to express everything in this declarative way?
Oh, another great question. So I would say it's actually very often a problem, but it might be coming from the way people are used to do things, not from the actual technical constraint. Like one part of it is because you need to, for instance, you need to install a certain library for your, let's say, Python application. Then you go and search. Well, you may be using Google or asking ChatGPT, doesn't really matter. And it gives you an apt run install instruction. Well, this is one part of it. It like a lot of information out there is for like good old way of doing things
Mhm.
by running commands first in just your shell console and then later on in run instructions. Then that's for package installation. Another part is, hey, I need to actually tweak something. So I need to modify a certain file or adjust a certain configuration in my image. And again, people are used to do like awk, cut, and grep, whatnot. But all of this is actually doable outside of your Docker file. So you can bring all this stuff from the outside by copying them. So at the first sight, it looks like getting rid of the run instructions might be problematic. But it's very similar to comparing like imperative programming and functional programming.
Mhm.
When you are used to one style, switching to another seems almost impossible. But then you start okay, I will do this tiny little procedure as a function. Okay, this worked. Then I'll do a bigger one, and then another one. And then a year into this process, you already cannot think in actually using your imperative programming anymore because you shifted your internal gears to this functional way of thinking. Or the other way around. When you don't do functional programming for a long time, you start thinking imperative again. The same thing comes to this Dockerfile construction. Most of the time, technically doable, requires some like paradigm shift.
So the TLDR there, it should be possible to express similar outcomes in a declarative way. And if you need to edit something, you just do it outside, maybe edit a config to adjust it to a specific image, and then you just copy it, right?
Or you just I mean, yes, for most cases, but if it's something more advanced, you're probably doing something wrong. You're probably like expressing your application logic in a Docker file, which you shouldn't be doing. This should be part of some other component of your application.
Totally makes sense. And then there's a fallback because you can build something basic declaratively and then add more using Docker files, for example, using the Chainguard base images in a Docker file is relatively straightforward. And then you get back those imperative constructs with the run instructions. So you can always cheat if you need to.
Yeah, that's a good one, by the way. Yes, yeah. Thinking outside of the box.
Yeah. Okay. So we have, and getting back to the APKO config file that you showed, one other question I have is about picking specific versions. And what you
Yeah.
showed for Python had a version number in the Python package.
Yeah. Yeah.
Is this how you would normally pick specific versions of the Chainguard slash Wolfie packages? Because normally the most of the configs I've seen, they just have the package name, not the version.
Yeah, let me. So I'm just trying to find out the update file. So, that's a good question. So I can pick another example. Suppose, so in my pipeline, right, I started with pointing at a certain version of the Wolfie package, right? And then we need to make sure we are always updating it. And if I say I'm building it from source, what does it mean exactly? And so in the minimal project, right? So there are different versions on how different ways in how we are actually building in images. So as you saw for Python, we are hitting the Wolfie package of Python. We are hitting the Wolfie repository and then building the image based on our own environment variables and everything. And another way is if I actually want to do it by running the make commands and making sure I'm downloading the tar file from the source repository itself and building it. That's also we are doing in minimal project. So if I were to pick an image example for MySQL, this is one of the heavier images that takes a lot of
Should,
time to build.
should you
Uh,
maybe zoom in
yes.
a little?
Oh, sure, sure. Sorry.
Oh yeah, perfect.
I'll just do this thing. Yeah.
Yep.
So this is like, so what I do is so all these, so these are part of the Wolfie action. So these are like different pipelines that are running on this GitHub project. If you see right there is this cron job that runs at 6:50 a.m. UTC. So what it does is, it tries to identify the latest version that we have for MySQL. Suppose we are looking for the version for 8.4.x, it will hit the so there are different ways I am looking for new versions for different images. And what I have also observed is there are different, like right now I'm hitting the api.github.com, right? I'm trying to identify the tags that MySQL project has on their official GitHub repository. And for some images I'm hitting the CDN links of these projects, depending on how these individual projects actually publish their version updates and everything, right? So here I'm hitting the MySQL GitHub repository, trying to identify the version, retrieving the version information, and seeing if it's actually not, if it's not same as the latest one, and then I update it. I then download that particular and then I have the checksum file as well, which is to make sure I have the hash value verified from the downloaded image and as that was published from the website. I download that latest version, and then I create a pull request where I update the version on the melang file of this MySQL image. And when the rebuild happens, the rebuild will pick the version that was updated, and then it will pull that particular MySQL version and build that APKO package, and then APK package, and then APKO file will pull that latest MySQL package. So it's running every day. It's updating the version numbers in the melang file, and then they are rebuilding the images, and then we have those packages available for APKO to build these images. I can show you I mean, this is the update file, but I can show you the MySQL APK and melang configuration that will make it easier to identify. So this is the packages, the repository that we are hitting, and then yeah, and then we are actually here. Like if you see this step right here, we are building the MySQL binary from source. If we have the cmake command here, and it's like the normal command, like it downloads the tar file from that update, and then it does the cmake thing, and then it will publish an APKO package for this particular binary that we will be ingesting it in this particular APKO file. So if you see right, we have the base layout, we have the core libraries, we have the protobuf, and then we have the MySQL minimal, our own MySQL package that we built using Melang. This is the APK package that we have built using Melang in a Melang configuration. And then we consume this in the APKO, and the rest of the packages we are pulling it from the Wolfie OS. And then we are building in the similar manner as others. Yeah.
And that answers this big question that I'm sure others will have. So if the official packages don't cover everything you need, what do you do there? And that's what you would do there. You would build from source, you would create an APK package, and then you would use that APK package in the standard APKO config.
Yeah. So if I were to go in depth here a little bit, like you can see, right, we are picking the version that was updated by the update pipeline that was running. We download it from the MySQL website, and then we run the build command. We have that. We install, and then we push it. We verify the build, and then we update it, push it as one of the APK packages that our APK file will use. And another thing that I have on my images is the test file, which is that can depend on what all different things you look for in your image. And so this is just to make sure the image that we built was actually good, and it was not trash, or it was not some inconsistent image that won't do you any good. So these are like basic tests that okay, the SQL is running, and if you want to hit a particular endpoint like a health endpoint, if your image supports that, you can hit that as well in some time frame. So in my pipeline, I have observed like these test files are actually have been proven useful, because sometimes when images are built and they don't have that particular configuration, the test will fail. and then I understand, okay, this package or this particular path was missing, or some permissions were misleading. So I have this test file that runs after we have built the image completely. So GitHub Actions run that image, and it makes sure the test passes before publishing it to the for others to use.
And that's one of the other benefits of the minimal project is that not only do you recreate the images that are a part of the official Chainguard images repository, you have a lot more images. So beyond that basic set, and you also have this end-to-end pipeline that
Yeah.
builds it, creates additional packages for custom packages that are not available in the Wolfie and Chainguard packages, and then it assembles them all together. It tests them, it scans them, right?
Yeah, yeah, true. So, like Caddy or Kafka was one of the examples. If you see, right, they are not available for public use. But through these toolings and everything, we have the ability to build our own Caddy images. And we have that image in our pipeline that we are building. Like, suppose Caddy, this image is there. You can use it, and so, because we are using the shared resources on GitHub Actions, right? There are certain limitations that we have to abide by for GitHub, and this is an open source free project, right? And like I'm not using any enterprise solution to do this, so we have to rely on some of the limitations that we have on GitHub Actions. But if someone wants to build their own pipeline and invest in that infrastructure, they can, and they can scale up as they want and not rely on external uh, resources or packages to build this thing. I mean, if some companies are not comfortable using Wolfie packages, then they can always build everything from source. It will just require more resources, but the tooling is there. That's what I wanted to mention. Yeah.
Cool.
Yeah, and when you build these packages from source, they automatically become like libc based, right? Because Wolfie
Yeah.
itself is not muscle based, so
No, it's not muscle.
yeah,
Yeah.
yeah, and you cannot reuse the like Alpine's standard packages. Well, have you actually tried it? Because it might work. I mean, technically, you would be able to pull this package, but then the resulting image will be most likely a mess, of course.
Yeah.
That,
Yeah.
that's a
It's
good
a good,
question.
yeah, good experiment to do as well.
Yeah, because you can also build Alpine images with APKO. You just point to the Alpine repositories, and then you say, hey, I'm going to install these packages, and you can have an image built declaratively. But mixing and matching the packages, it's based on what I've seen, it's not supported, but maybe you can have something functional because you can install glibc in Alpine and do other tricks to make it work. So I've seen stuff like that too.
Yeah, yeah. And another thing I'd like to show about the minimal image project is we are we use Cosine to sign our images, and then we also publish at this particular endpoint, right? We also publish the CVs for each of these images, and they are updated daily based on the actions whenever they run. And I run a gripe scan on all of these images, and you can see the latest, like it also highlights the commit when which these particular data was available from. So I mean, this is not. So the schedule here is limited. I mean, I think Chainguard has even rigorous schedule, and they keep on updating their images more frequently than minimal. They have the resources and they have the infra to do this, so it makes sense. But I try to update it daily, and if you see, right, lot of it R0, lot of it. So if I were to pick the etcd, these are like not fixed from the source itself, and they exist. And it's possible like these same vulnerabilities, CVs, are also existing on Chainguard's images as well. I can.
Yeah,
Okay, yeah.
what you could probably do is like just go to Docker Hub, pick the Python image, and then compare it with your CV
Okay.
numbers. I think it will be
I
an easy.
have. I can show. So I can run. I can pull and run the gripe command if you want. on this
No, not
on the Docker?
necessarily. Docker Hub, it shows already some numbers. I mean, it's not. It's a different scanner, so it's not exactly apple to apple kind of comparison. But
Yeah.
I think it will be representative enough.
I think. Do you know where exactly
Yeah,
we
just
can?
go to tags, and there are type
Oh,
something
okay.
like 3 dot. Yeah, so at the top there is tags, a sub tab, all like this. Yes.
Oh,
Yeah. So here, if you type like 3.14 bookworm or
okay.
3.14
Oh,
Trixie.
you mean this?
Yeah,
Oh,
yeah.
okay.
Oh, yeah. So you can see them. So this is, for instance, a dev or a build
Yes.
variant of this image, which like the one that I call the fat one. And yeah, and it's pretty bad.
Yeah.
It
Yeah,
has
yeah. You can
17.
see the size 366 MB and 17 high CV, 15 medium, 203 low.
Yeah,
Um,
this is the image you would probably want to use if you would want to use it only for the build stage, and
yeah.
definitely not for the runtime stage. Now, if you compare it to the 3.14 dash bookworm dash slim, the slim version will be much better. I expect no critical so high be there, but I think it will be still not as polished as your minimal image.
Yeah, yeah. I'm just trying to see if where do we
You
have
can
that
just
picture?
type it in on the tags tab. If you type in 3.14 dash slim or something, dash slim, it will show up. Docker Hub is not doing great, right?
Yeah, it's bad. Seems like.
Or like dash Trixie dash slim or
Oh,
dash
okay.
bookworm dash slim. No.
They don't have the film image for this. I can. So this one, the Python image that we have on Chainguard, it's I think
Oh,
the
it's dash
version.
slim dash Trixie. Oh, so slim
Okay.
comes first. Yeah, if you like, I can send you a link. Um,
It's here. Yeah, it's still 8 ICVs for the bookworm version, medium 5 and 35 low. I mean, the size is definitely 43 megabytes, so that's
oh
good.
yeah, it's
Yeah,
much better size wise. Yeah, but still there are some even some high severity vulnerabilities.
yeah,
I actually expected it to be more like zero. And now let's compare it with your minimal image.
sure. I'm just looking. So this is the version that we have on ChainGuard 3.14.4 R4. Its size is 23, and I think they have 3 CVs in here that are all medium. And if we were to look at our Python image, we have 5. We have one critical, high CV, one low. Yeah.
So it's 1, 3, and 1, right? And on Docker Hub, it was more like
Yeah,
4,
it's 8,
4.
5, 3, 5.
Oh yeah, I'm looking for some weird platforms like Linux 386. But if you look
Okay,
at
okay.
the next one, yeah, like the second one is yeah, yeah. So it's
Yeah,
four
I
times
think
worse. Yeah,
let me run gripe on the Python
yeah. That
image.
will be a
So
more fair comparison. Yes.
yeah, because this particular website, the CV count information, it's I think the data might be stale, and then it's the fixes come pretty quickly. I just want to make sure it's same because if it's less, it might get updated tomorrow. So yeah, that's there. But yeah, I mean, definitely we can see the difference here itself, right? We have 5 CVs on our minimal project. Chainguard has 3, and the size is pretty less as well. I mean, we can see right here it's 43 even for the slim image. Chainguard is 23, I think. Yeah, I think our project should be around that itself as well. Oh, see, we also have 3 itself on our Python minimal.
Yeah, you always get something, and if you
Yeah.
look at the vulnerability results on the Chainguard page, you get matches. So technically, it's not 0 CVEs, but the CVEs that show up a lot of times they won't fix or irrelevant and all of that.
Yeah,
They just
yeah.
show up as noise.
Yeah. So, I mean, if we were, I think that vulnerability count information on that page will be updated tomorrow with this latest CV count. But if I were to pull that particular image and run Gripe on it, we have same number of CVs as the chain guard has on their images. Yeah, we can
Yep.
see here, right? That's good.
And since we are doing this, maybe you could run it against this Docker Hub image just to be
Uh,
able to compare
I
it
don't think
like
it. I don't
apple
think
to
it.
apple.
I don't think it will fit in a. It will fit in that one page.
Good one.
I'll just run on the
No,
latest
don't
one.
run it against. No. This is a wet image. You need to run it against
Slim.
like 314-Trixie dash Slim.
Okay. Okay.
Yeah, the Python latest would definitely not fit into one page, like not even into 2 pages or 100 pages.
Yeah, I think Gripe should pull that automatically.
Yeah, that's a good one. Like this image is what I would actually use most of the time, personally.
Okay, bookworm. Okay.
Okay. So
Kyle,
one
do
of the
you have
things.
some comments on the images we see on Docker Hub and Chainguard and Minimal?
In addition to that, so one thing that will be good to see is what I mentioned in the beginning, whether or not we can build the exact same image Chainguard has with their official tools in their Chainguard images repo, and then see how different it is or how similar it is. So after we do this, how about we try doing that to see if it will be successful.
We keep losing Ritvik.
Probably because he's pulling the Docker image and it uses up the bandwidth.
Yeah. I think we actually we got a very nice.
I told you it won't fit in a page.
Welcome back. Yeah, so that's a great comparison, right? So it's at least 4 criticals and a dozen of. Now, yes.
Okay. Yeah, sorry, you were saying something, Ivan?
Oh yeah, I was looking at these at the scan results, but yeah.
Oh, okay, yeah.
So now if we compare it to the minimal image you built in your project and which is very close to the official Chainguard image, if not identical. It's 3 medium severity vulnerabilities versus 5 high severity or 5 criticals. What was it? Or like 4 criticals. 5 criticals, yes. 28 high, yeah. So like you cannot really even compare it. So quality-wise, it's like a no-brainer, right, to choose a minimal Python image. But then UX-wise, what you get with this Docker Hubs Python image, you get your traditional run instructions, and you can apt get install anything you like. And on the other hand, you get this Chainguard way of doing things with ABKO. So that's your call to make. What bothers you more, right? If it's the like scan results and staying compliant and or more secure, you go one way. If it's more the DevX part of it, or you think all these vulnerabilities aren't really exploitable in your particular context, then it's
Yeah.
the other way probably. I think this partially answers this question we got in the channel like 10 minutes ago. What's the point of using the APKO way or declarative way versus the run instructions and a traditional multi-stage? Even if you go with a multi-stage build and perfectly craft your Docker file to copy only the necessary parts from the build stage into the runtime stage, the best base image you can get for the runtime stage, if you go with a traditional way, is this Python image, and it has 5 criticals in it. So of course, there is the slimmer version of it. You can try using the JCR distroless Python image, but this one is already so trimmed that it may already impact the DevX at production, or like it's not DevX, right? It's operational experience in production.
Yeah.
Yeah, so that's it's not like there is a single right way, right? It's always a trade-off, and you just choose what you want to optimize for.
Yeah, and I don't think it's easy as well to identify exactly what you need in your images as well. But like you said, Kyle, like sorry, Evan, what I've observed is like if it's very hard to nitpick these packages, and it's hard to determine okay, this CV affects you or not, because you will have to make that decision for every CV that you get in these images, and every day these count differs a lot, right? So operationally, I don't think it's feasible and possible for anyone to sit and identify if your organization is like big enough to say like, okay, this CV affects us. You'll have to have like good asset management of your whole company and infrastructure to identify like, okay, we are aware of our systems end to end, and okay, we are not using this technology anywhere, so it's not possible for someone to exploit this CV, right? So I think to adding to your point, right, operationally it's very hard, and it only gets difficult as you increase the infrastructure and load on your projects, right?
Uh, if your company is of a certain size, right, or if you are a small shop or an indie developer like myself, like okay, I mean there are 5 criticals or something. I don't like necessarily have to even think of them, because well, this image is out there. If there will be something really critical, it will be all over the news, and then this image would eventually get patched. But otherwise, it's probably something not exploitable unless a very specific case. And then if the rest of your hardening is good enough, like if you are inside a secure perimeter and no one can actually access anything but your port 80 or 443, then probably it's fine to use this image. So again, a trade-off.
Yeah, that's true.
Cool. So are we ready to see the official Chainguard repo and their images?
Yep, let's go for it.
Okay, I'm gonna edit.
Okay. Should I stop sharing?
It's okay. It looks
Okay.
like we're good with the setup. So here I'm in my copy of the repository, and what I did, I listed the content of the images directory where they have the images that they officially support in that repository. The complete catalog has a lot more images. So this is just the publicly buildable images, mostly the runtimes and common tools, but it doesn't include everything. So this is one of the benefits of the minimal project, where you get additional images that you wouldn't get from this official repository. Now, one of the official public images here is actually for the Min Toolkit project. The team was nice enough to create the image when I asked for it, and it's still there. And then here I listed the content of the Min Toolkit debug directory. And if you look at it, you'll see a bunch of the Terraform files, which is not the same setup that you described. And a little fun fact, originally the repo had those APKO configurations, and it still has it for the static image. If you go to the static image, images/static, and the configs directory, there's still wolfie.apko.yaml file. But for the rest of them, it's the Terraform configurations. And at a high level, what they do, they try to dynamically generate the APKO configurations. It's just not obvious, especially if you're not a Terraform expert. And then if you look at the configs, for example, for the Min Toolkit config, and if we look at the main.tf file in the configs in the config directory main.tf, we'll see that it has this list of shared packages, and they list those packages. And then what they do in the Terraform, they combine those shared packages plus the extra packages, which are defined in the main TF file in the root directory of the image, main.tf. So if we look at this, we see that there's the extra packages variable defined with crane, grpc curl, and auras and yq. And then it get passed as a parameter right there, and with all this magic, it ends up creating an image, and you create it with the make image / image name command. So if I do make image min toolkit debug, this will kick off quite a bit of magic, because they actually stand up a registry internally. And here it's asking me the name of the repository to use. So if you set it up yourself, you need to authenticate to your GitHub repository so it can push the image there. Min toolkit. I'm going to use the Min toolkit Docker Hub repository. And then it's going to go through the build steps. There's a lot going on there. So the main thing after you get it all set up, the main gotcha, if you don't configure it properly, the tests don't run well, they fail. And that's why for these images, I ended up skipping image tests, but there is a way to make it work. I just decided not to, because I ended up getting the images that had the exact same digest that the official images had. So I assumed, well, if I get the exact same digest, then it means the tests that they run can be transferred.
If they run.
Yeah, if they run them and they're successful, that means it's good for my image, because I get the exact same digest. So once it completes, I'm gonna run a build on the Python image.
So let's see if I understand this. We have these APKO files, right? YAML files, and the YAML files just describe the needed packages to compose an image statically, right?
Hmm.
And that's what Ritvik's project uses to build this alternative collection of minimal images. But now we get back to this official Chainguard repository. Instead of static YAML files, we now got a bunch of Terraform files. And do they use them only to dynamically produce APKO YAML files? Or is there some extra magic that happens behind the scene?
Oh, there's a
Yeah.
lot more. There is signing, testing, and pushing the image and all of that. So it's not just building the image.
So this Terraform is used not only to produce the image, like the input for the APKO tool, but also like the whole pipeline happens through the Terraform files.
Yeah. For example,
Okay.
right there, I started running the build command for the Python image, and here it says using previously installed Chainguard dev dash dev cosign, and it's used for signing and all of that. So it's a lot more stuff there, and it pulls the OCI package or a module there, and the image test module that they use for testing, which I skipped with the config. So there's a lot more there, but that's what makes it complicated, and that's where people get stuck. And I've seen repo questions. So where are the APKO files? Because people, based on the original posts and videos, they expected to see them there, but now they're not there.
Yep. I mean, I would expect them to be there too.
Yeah.
And am I getting it right that Ritvik reproduced a very close to this pipeline, but in GitHub Actions using a more traditional like YAML slash bash kind
Yeah.
of scripting?
True, true. I mean, so after doing this minimal project, right, I realized like the scale at which Chainguard pushes images and build these images, right? It's fathom. Like you cannot even imagine the resources and the computational capacity and complexity it creates. Well, the number of packages and number of libraries they have to support, and these pipelines and these images infrastructure, right? I feel like this is all very fragile. Even a small change, suppose if I'm looking for a certain version on the upstream, if they change it even by something, your pipeline will break because your YAML file or your configuration is not supposed to like not expecting that value, right? And then you have to that build will fail. You'll have to refix that, and that happens across the board, like because it's not one single developer building these things, right? There are whole different organizations, there are package managers that are building these tools, and they have their own way of doing this stuff, right? So these things keep on changing and your build keeps on failing. And I was reading like some of the Chainguard blogs, and I felt like they also have this same issues, and now that's why they have built their own driftless approach, where they have like reconciliation method, where they try to they it's like you try to make your system go into a desired state in the way you want. And I think that's the reason that they have moved to this Terraform approach. Probably it's easier for them to manage this at scale, moving away from those APK or YAML files or Melang YAML files. Yeah, that's my guess. And I think the Wolfie package, or like Wolfie repository we saw with all the package information, right? Initially, I think it's now being moved as a mirror of their some internal repository. So I think if you don't want to rely on Wolfie completely, it's possible like there might be a certain delay based on their SLAs that they have on updating these package versions internally. So you can also hit the official source and get that, but that will require some more resource and like computational power to do that. I mean, I'm relying on GitHub Action, so as far as GitHub allows me to do these things, I will keep on doing until I hit a limit and I'll have to pay.
And that's how you come to appreciate what Chainguard does, and
Yeah,
maybe
yeah,
even
definitely.
justify the price of these images a little.
Maybe. Yeah.
So we got the build results. So the make command for the Python image finished, and we got two tags, one for the latest and one for the latest dash dev. Those are the two flavors Ritvik mentioned, the dash dev has additional things in it, including the shell. And then I tried to pull the latest version for the Python image from the Chainguard repository, and I got the exact same digest. So if we look at the digest, SHA-256, it's 66A EE22 F77, etc., etc., and the image that I built has the exact same digest there.
Yeah, that's very cool.
So
That's
we
awesome. Yeah.
so we got a reproducible version of the Python image exactly that Chainguard provides, and I was able to build it with their Terraform tools. But I would still recommend using your project because it has additional images and it has more of an end-to-end setup that you can adopt easily. So
Yeah.
what are the steps to use the project that you have? So just cloning the repo and that's it?
So it depends at what level do you want to use the project. So I can show. So I am publishing these packages on GitHub's repository as well. So they are available to be pulled from GitHub's own repository. These are all public. So you can just pull this image like a normal Docker container image and just start using it. And if you want to build these from scratch, I don't know why, but that's if someone wants to contribute to this project, add more images. I have tried to publish a contribution guidance and like how you can actually build. So what I look for is typically the standard APKO files, Melang file, and make sure it is actually working and it's building an image that are passing these tests as well. But if you want to try this minimal project images, I think the best way to start is just pulling these packages, these Docker images, and start using them. So these are all like also tagged based on their version updates and everything. I'm trying to follow the approach that Chainguard has. It has not been easy. It's pretty complex, but uh, like if you can see, right, this is the 3.14 for R4 and this is R3. It was updated like 13 hours ago, and you can just pull it and run it like a normal Docker container image.
So that makes sense. First, start by pulling the image that you already built.
Yeah.
Second, if you like it, looks like it fits your needs, you can clone the repo and own the end-to-end pipeline if you need more determinism and more control. Step three,
Yeah.
customize it wherever you need to. And step four, ideally contribute back wherever
Yeah, that's
possible.
very important one. Yes.
Yeah. I mean, it's so I had like I have some developers who have actually contributed to certain images. Like CUDA image was there that was requested from one of the developers, and they submitted the files. There was another one. So I have like it's good if community comes in together. They whatever image they want, they try to build these files and they push it here, and we can have a pipeline making sure we always have the latest version, minimal images that they want. And if they don't have the setup and they don't want to go through the entire hassle of setting up the pipelines, it's easier this way. And I would agree, like this is not a traditional Docker file, right, that people are used to. Like Docker made containers so accessible and so easy for everyone to use, so people are used to that. And it like some of it's always possible, like their requirements are maybe fulfilled by normal Docker files, and they don't need to go through this complexity of using Chainguard images or minimal images. That's totally fine. But I think, like as we discussed earlier, like Chainguard is trying to move away from Docker files, and probably minimal is also an initiative in a way for that. Maybe not completely remove it, but as a possible alternative that is also feasible for people to use. And they don't trust, they see what they are actually consuming. Like this minimal project also gives them a view, like, okay, these are the packages that are being used in my images, this is the source that image is hitting from. And we have like verification process in place. There's the CV count that we are publishing, there is SBOM that we have. So everything is in there, they have visibility on whatever they are consuming. So that's also, I think, if someone is cautious about whatever image they are pulling and running into their environment, they have visibility on that.
And one thing I'd love to add to it, related to the declarative way of those images. When you create an application, let's say we take that Python image. When you create an application, given that it's still a generic image, even though it's a minimal image and it has patched a runtime and patched packages, it's still possible that you don't need a lot of the packages in the image. So what you can do, you can create your own custom version of the Python image that you use to build your Python applications, because you know that you don't need a third of those packages. So you can fork your repo, customize it, and then and then remove the packages that you don't need, and now you have a custom version of the Python image that fits the applications that you have. So this is the powerful part of this setup, is that you can easily customize it.
Yeah, yeah, I totally agree to that. And I'm just trying to show the pipeline. So I have like the initial version of minimal was not at all efficient. It was running the pipelines even when I had changed just one image. So I have to slowly and slowly I've tried to optimize the project to make sure it only runs the pipeline that have been affected by the changes we are pushing. So, and if I were to show like what exactly we run on the Melang and the APKO pipeline, so this is the steps that we have on the Melang part. This is all coming from that YAML file that we saw earlier. So we have the signing key, we have the Go version from Wolfie. We are building packages with Melang, and we can see the instructions and logs that we have, right? What are they doing, installing, and then there is this. So also like we are supporting two different architectures here, right? One is like 86, and then the other one is the ARM, and this is the APK pipeline process steps that go through when we are pushing these packages. So we have download these packages that we built initially in the previous step, and then we combine them, we merge these packages into one image, and then we have the signing key, we build them with APKO, like APKO build command. This is the standard that we have, and then we report the image size, we have we run the gripe scan through it, and we publish that report so it's visible. We then test that image. Before publishing, we make sure we test that image, and then after the test pass, we publish that image. So these are the steps that actually happens. These are all coming from that YAML file that we saw earlier.
Very cool. And before we wrap up, I wanted to mention that as a follow-up, we'll have a playground using server lab setup that Ivan has. We don't have it yet, but we'll have it soon, probably this weekend. And this is the easiest way to try building the images and possibly customizing the Python base image that you can then use for your application images. And then we'll post the links, yeah, once the playground is available.
Yep, that's a hopefully a valuable addition to this, because experimenting with this stuff requires installing all the tooling, and installing tooling is a separate challenge, right? So it's nice to have this, well, a playground, literally, where you already have the stuff pre-installed and you just focus on the actual task at hand.
And we'll have the official Chainguard repository with the extra tweaks to make it usable as well. So you can repro my build steps too.
Yeah.
Awesome. All right. I think it was a great session. We learned about this awesome project. And again, it's super powerful because you can customize it, and it's a full end-to-end setup, and you can own it, and it's not that difficult actually. And you've done the hard work of reverse engineering the Chainguard image configuration, and now others can take advantage of it. Thank you.
I mean, if someone wants to have their own version of minimal image, they just need to change the APK and Melang configurations, and then they have everything of their own.
Great. Thank you. And again, we'll have a follow-up online with the links and the playground.
Yeah, and go check out and star Ritvik's project, and please contribute back if you add an extra image or two to it.
Yeah, exactly.
Thanks,
Thank
Eva.
you. All right.
Thank you all.
Awesome.